Hello, everyone, and thank you for joining us today. My name is Mike Scancarello, and I've been involved with the ACE Mentor program of Rhode Island as a mentor since 2014. I'm also a structural engineer at O'Day Engineers in North Providence, Rhode Island. As a mentor, I've enjoyed working with students and my other mentors at the Northern Rhode Island location that's hosted at Blackstone Academy Charter School in Pawtucket. I and the rest of the mentors really love what we do as architects, engineers, and construction professionals, and seeing high school students discover those same interests drives our mission with ACE. Today, we hope to introduce you to all of the ACE Mentor program and the value that it can provide to high school students, especially those who might consider a career in one of the ACE fields. After a brief introduction to ACE, we'll talk about some of the specific opportunities like scholarships that ACE provides, and then discuss how we'll run the program this year. We'll then hear from Edwin Montez, a former ACE student who is now a mentor and works at the Kilbane Building Company in Providence. We'll also have an opportunity for a Q&A to answer any questions that you might have. For those who are able to stick around after the Q&A, we'll hear from a wide variety of ACE professionals who will introduce what they do in their day-to-day work. So what is the ACE Mentor program of Rhode Island? The ACE Mentor program of Rhode Island is the local affiliate of the ACE Mentor program of America and is a free after-school program for high school students interested in careers in architecture, construction, and engineering industries, including skilled trades. Meeting weekly from October to March, the program here in Rhode Island is entering its 17th year, offered at various locations around the state in partnership with the local schools. For 2020, ACE-RI will be transitioning to a virtual program until it's safe to return to our regular in-person mentoring. As part of the program, students will meet on a weekly basis to complete engaging hands-on projects. Each day's activity consists of some introduction to the topic we'll be focused on and its application within the ACE industries. We feel the most learning is achieved through completing projects under the guidance of the mentors, so a major focus of the first-year program is hands-on projects. Throughout the year, these activities will build on each other to give students a holistic understanding of the ACE field. The first-year program is open to all high school students. Those who join the program before their senior year are also able to come back each successive year as returning students. Returning students apply the knowledge they learned in the first-year program to a design competition where they compete against all other ACE affiliates around the country. The design competition changes every year, allowing students to be a part of ACE all 4 years of high school if they desire. As recently as 2018, an ACE-RI group finished in the top 3 of the competition and was invited to present their project to a group of industry leaders in Washington, D.C. An important part of the program is the relationship and guidance the students receive from the mentors. Teamwork is a core principle of the ACE profession, and group work led by a mentor is an emphasis of the program. All of our mentors are full-time ACE professionals from around the state with various backgrounds and expertise. In the past, ACE has been an in-person program with 4 different locations in the state. Through the partnerships with local high schools and universities, we've been able to offer these hub locations where students from across the state gather with students from other schools. While we hope to return to some form of in-person mentoring, we'll be going virtual for the fall 2020 sessions, and we'll continue to reevaluate as our public health situation evolves. We hope to return to in-person mentoring as soon as it is safe to do so. We will have virtual sessions available for the entire school year. Because we're going virtual, the activities are going to look a little bit different than you see students doing here. Our schedule is flexible each year, but here are some of the activities that we do every year. Our sessions include architectural topics like space planning, engineering topics like structures and resiliency, and construction topics like project management and cost estimating. Through office and college tours, we'll also introduce students to the next step on the path to careers in these professions. In addition to the after-school activities, the ACE program strives to support students after they have graduated. Part of this support comes from the relationships students can build with mentors, and part of this is through the scholarships that are awarded each year. In 2020, ACE-RI awarded a combined $30,000 in scholarships to 10 students, ranging in value from $2,000 to $4,000 for their first 2 years of school. Over the past 16 years, over $200,000 in scholarships has been awarded by ACE-RI. In addition to the local scholarships, ACE-RI students are also eligible for the CMIC Allen Berg Scholarship, which awards scholarships from $10,000 to $40,000 to students around the country who have completed the ACE program. In 2019, the Maximum Value Scholarship was awarded to an ACE-RI student who is now an architecture student at RISD. You can learn more about Lily's story on our website. We'll now hear from Edwin Montes, a former ACE student who is now a mentor and works at the Gilbane Building Company in Providence.
Hi everyone, my name is Edwin Montes and I am a project engineer at Gilbane Building Company. A fun fact about myself, I am an ACE alumni. I had the opportunity to get involved with ACE when I was a sophomore in high school. At ACE, we talked to real-world professionals about architecture, construction, and engineering. This was also because I was able to ask them questions on what is it that they do on a day-to-day basis. This helped me narrow down my interest in construction management, eventually landing me an internship at Gilbane Building Company, one of the top construction management company in the U.S. today. In addition, at ACE, I participated in the ACE National Design Competition. This was awesome because we were able to team up with different students all throughout Rhode Island. Some designs included the 2012 Olympic Stadium, a multi-city park, and a modern high school. If it wasn't for the ACE program, I would not be here today. I truly believe the ACE program paved the way to my career.
I hope this overview of the ACE program has sparked your interest and that you will join us this year to see what a career in an ACE field is all about. Our fall sessions will be held weekly on Thursdays starting November 5th, are from 4 to 5:30 p.m. via Zoom. If you'd like to join us this year, the next important step is to register. You can find links to registration from the student page of our website, where you click to join this session, or you can also find the registration directly on the ACE National website. Students, please make sure you have a parent complete the parent consent form when you register. We'll be sending out an email to all registered students with the information to join the weekly sessions prior to our first session. Thank you everyone for taking the time to join us tonight. I hope this presentation was valuable for you and I hope you'll join us this year. This concludes the formal portion of our presentation, but please stay tuned to hear from several ACE mentors about their experience as ACE professionals. If you have any questions, please contact us at acementoringri@gmail.com.
Hi everyone, I'm Tammy Hughes with DBBW Architects. Here you are in my office, and I'm going to show you a little bit about what I do on a daily basis. So as architects, we usually get hired by the client who has an idea for a program in a building that they would like to design and construct. So we come in and we help them put those ideas together, help them organize their program, and then make that into a reality. Oftentimes, if we're doing a rehab project of an existing building, and it's quite an intricate one, we would hire somebody to do a laser scanning that kind of helps us have the building virtually on hand all the time. So I'm going to show you some of the technology that we use. As you can see here, this is the laser scanning of a building that we did. I've just kind of zoomed into some areas, and I just wanted to show you that with this, you can really kind of walk into any space and take a look at, the conditions that are there. So if you forgot to take a dimension, for example, for, where the trusses are in relationship to the floor, you can do that right here on the point cloud. We then take that information and put it into Revit, which is the tool that we use for constructing our documents. And here we have a full model of the whole building. And actually, this is the existing building. And then this is what it will look like when we are done with that. And then as you can see, we have some renderings of the interior that we do through Revit. And then ultimately, our construction document set that goes in here. So that is just a very small portion of what we do. We also have an in-house interior designer that helps us figure out what the spaces are gonna look like and really take a look at the colors and the textures. So here's Sarah to tell you a little bit about what she does.
Hi there, I'm Sarah Whiteley and I work at DBBW. I am the senior interior designer here and I work with all the architects on all the projects that we do in the office. Oftentimes when we're working on a project, we get into the interiors of a building, and that means we have to select things like carpet and tile and wallpaper and wood and fabrics. And so we have what's called a finish library, and that's what you're seeing here is we have everything from carpets to LVT tiles. We've got bins and bins of fabric. We even have a lot of architectural finishes that the architects often refer to, like windows and ceiling tiles and metals. So if you follow me this way, we have a whole section here that we have roofing tiles, we have exterior stone. So when we're working on a project, I will oftentimes come in here and start pulling things out and looking at what works for our project. You know, is it going to be a palette of bright colors, or is it going to be something a little bit more conservative? After we do that, we put together a presentation for the clients, and oftentimes we do that on a board. This is an example of an elementary school we did, hence the bright colors. And this is just showing all the materials we're going to use throughout the building. So we have flooring, we have paint, we have carpets, and this is a way for our clients who aren't always visual people to be able to see and feel and touch everything that we're going to put into a building.
Thank you, Sarah. And apart from Sarah, we also have an in-house renderer who helps us get our ideas across to the clients and also put materials together for fundraisers. So here's Matthew to tell you a little bit about what he does.
My name is Matthew Valero. I'm a designer and architectural illustrator at DBVW Architects. A design illustrator, also known as a visualization artist, is going to be responsible for collaborating with the various teams in the office to generate 3D design models, renderings, and other graphics, including animations and VR experiences, in order to review and communicate our design ideas. The process can start with an idea, sketch, CAD file, or an existing 3D model from SketchUp or Revit. I'll sit down with the design team and get an understanding of what it is they'd like to see and how we will be showing it. Then, after using 3D software, I'll turn those ideas into a design model. After the modeling is completed, we will create realistic looking materials and lighting within a render engine that'll bring the model to life. At this point, I'll create preliminary images, sit down with the design team again, review the model, and make any necessary changes to the design before we finalize those graphics and present them to the client. Final renderings that are produced play a vital role in communicating our vision for a project to the client, getting local approvals, fundraising, as well as marketing a project and creating excitement in the community. Typically, renderings are created as still images that can be printed or displayed on screen, but recently, with technological advances, especially in the gaming industry, a whole new world has opened up for ArcViz. We're now using some of the same software that you've seen in games such as Fortnite and utilizing those gaming engines for rendering purposes. This technology now allows us to virtually step inside of a project, fully explore our designs, rendered in real time, then quickly generate compelling animation and interactive imagery, which has now allowed us to envision ideas quickly and effectively. A visualization artist wears many hats: designer, modeler, photographer, cinematographer, and artist. We play an integral role in the design process, and as rendering technology keeps advancing, I see that role becoming an even more exciting part of the profession.
Thank you, Matthew. So as you can see, there are many things that we need to do and coordinate on a regular basis in order to ensure that the building meets the client's needs and for the program, and also the code regulations. Once a building is underway and is being constructed, you can often find us on site, making sure that the construction documents are being followed and that the details are being built the way that we designed them. But none of these construction documents would actually be possible without the help of our engineers. The engineers and us, we coordinate on a regular basis. You often see us on emails and telephone calls on a daily basis in order to be able to make sure that we are coordinating all the building systems with the design of the building, meeting code, and also fitting in the program requirements and making the building aesthetically pleasing and functional. So here are some engineers to tell you a little bit about what they do on a regular basis.
Hi everyone, my name is Mike and I'm a structural engineer at O'Day Engineers in North Providence. I've been involved in ACE as a mentor since 2014. As a structural engineer, I work with architects and contractors on a daily basis to see our projects through to completion. There are two main tracks in structural engineering, bridge engineering and building engineering. While some structural engineers do both, my education and previous experiences covered both. As a building engineer, I focus primarily on the design of buildings and vertical structures, and less on the design of bridges and road systems. To really simplify my responsibilities, I like to tell people that my job is to make buildings stand up and let others make them look nice. In reality, there's a lot more to it than that. Every day, I spend my time problem solving with three main goals: safety, function, and economy. As engineers, our first responsibility is to you, the public, to ensure that every building you enter is safe. My second priority is function, because if the building didn't function well, no one would want to use it. My final goal is economy, because no budget is unlimited. If the building wasn't affordable, it wouldn't be built. Finally, an underlying theme in all of these goals is sustainability. Like all professionals, there are a lot of tools that I use to do my job, and knowing which tools are the best to use and how to use them are some important skills. My most basic tool, believe it or not, is a pencil and paper, and maybe my calculator. I have a lot of references that help simplify my job too. When the calculations become a bit more complex or repetitive, I might use some tools that you are probably familiar with, like Microsoft Excel. Here you can see one of the tools that I built for occasions when another software wasn't available. Sometimes we use similar programs that allow our calculations to look like they were done by hand, but are automatically updated by the computer every time we change an input. All those things that we just saw are great tools and things that we can easily customize. But when it comes to the design and analysis of an entire building, we also have some specialized three-dimensional programs. These tools help us make sure that under normal loading due to gravity and the building occupants, the structure will be strong enough and safe. We also use these programs to make sure that the structures are comfortable and function for the occupants. You probably wouldn't like it if the floor of your classroom or office bounced every time someone walked by. And if you're using high-powered microscopes or other laboratory equipment, it might not even work if the floor was too bouncy. While we don't live in an area with the same amount of earthquake risk as everywhere else in the world, every building is also designed to withstand horizontal forces from seismic activity as well as high winds. These 3D analysis programs help us illustrate what buildings look like under simulated earthquakes and hurricanes. If you thought those buildings are moving a lot, don't worry. We exaggerate the movements to help us visualize them. Well, we won't be using these 3D analysis programs at ACE this year. I didn't even start using them until my senior year of college. We will be introducing you to all the fundamental principles of structural engineering. Instead of computer models, we'll build some hands-on physical models out of everyday materials. And one of my favorite activities, we'll glue together a few pieces of foam core, which is kind of like cardboard, and show that some configurations can support 20 pounds spanning 3 feet without even breaking.
Hi, my name is Victoria Holland. I'm a project engineer at PAR Corporation, and I work in their civil site engineering group, and I'll talk a little bit more about that later. I'm originally from upstate New York. I went to school, I got my bachelor's at WPI. I did my master's at Northeastern. And I'm also a registered professional engineer in the state of Rhode Island. I come from a family of, not a full family, but a decent family full of engineers, dating far back as 1921. And I recently acquired this survey equipment, which this is what we would use, well, not me personally, but this is what they use when they're trying to map out an existing conditions plan, try to understand where property lines are, what the topography of the site is. This is all manual, so the equipment that we have today does this digitally, and we can almost immediately export that into our computers and run some computer programs to generate an existing conditions plan. So I have no idea how to work this, is long story short. But there's some people that do. So what does a site civil engineer do? The easiest way to describe it is pretty much everything outside the building. So things I think about are, where are the doors? How do people get to the doors? What is the building being used for? Do you want to have separate staff come through one door, visitors come through another door? Where are the parking spots? How many parking spots do you need? Where's the loading area? Do you need a loading area? What about dumpsters? Can a trash truck come in and actually pick up the dumpster and leave the site? Or is it too tight? Safety is a huge, huge concern of what I look at when we're kind of overviewing a site at a high level, making sure that there's safe vehicular and pedestrian separation, and that if people do have to cross the street, there's a safe crossing and cars can see them. The other thing that I think about a lot is stormwater. So when it rains, before the rain hits the ground, it's clean. It doesn't really have much to it besides water. And as soon as it hits the ground, it picks up pollutants, sediments, anything that you and I, cross over on the street, or that gets thrown on the street or left on the street or overflows or things like that. So as soon as it touches the ground, it becomes dirtier. And before it gets back into generally a lot of the stormwater overflows into our waterways and our water bodies, and making sure that the water is clean before it goes into our water bodies, because we don't want to make our water bodies dirtier. We also think about quantity of runoff, because as we're putting more impervious surfaces on the ground, there's less opportunity for the water to get back in the ground, and instead it runs off downstream, hopefully not to your neighbor's property. So a way to manage that is stormwater best management practices, or low impact development practices. And what that is tree box filters, permeable pavement, bioswales. There's lots of different opportunities that we can design, and it's actually required by the state. And we can help the owner, the developer, kind of have a site that's going to improve the condition in the future. I hope this was helpful, and I look forward to speaking with you.
You probably ask yourself, what do project engineers do on a day-to-day basis? As a project engineer for a construction management company, I assist the project team in obtaining, evaluating, coordinating, and distributing the information necessary to construct the project on time and with a budget to the quality specified. Some of my daily tasks include ensuring contract documents such as drawings and specifications are maintained and updated as needed. To accomplish this, we use programs such as Procore, which allow us to share live information with the clients, the architect, and the trade contractors. This is important because we don't want the trade contractors to be building out of the wrong set of drawings. In addition, project engineers process and distribute submittals, requests for information, also known as RFIs. Submittals in construction management are shop drawings, material data, samples, and product data. Submittals are primarily required to verify that the correct product is being installed. An example is tiles, flooring tiles. The trade contractor will submit the product data and samples of the flooring tile. The construction manager will review them. Then he'll send them off to the architect to review them, and then they'll come back with comments. Either approved or rejected, we'll send it back to the trade contractor, and then we'll proceed accordingly. RFIs is simply just searching for more clarifications on the plans, on the drawings, and specifications or agreement. It's basically a question, to the architect or the design team. In addition, as project engineers, we seek to understand the customer goals and needs. At the end of the day, we're delivering a product, so our number one mission is to make sure that we're satisfying our client. Lastly, we want to make sure that all planned deadlines are met. This is very important because we want to make sure that we deliver the project on time to the client. So this is a summary about what project engineering is. You'll be able to learn more about project engineering and other construction-related careers once you join the ACE program. I hope today that you learned a little bit about what is it that we do and how this program could benefit you. Thank you for listening.
Hi everyone, Mike again. This time I'm coming to you from my virtual office. I'm sure by now most of you have heard of virtual reality and have probably seen a video game in VR. While I'm not much of a gamer, I do use VR on a regular basis at work. The setup you see here lets me view my monitors on the screen in front of me. I can also draw on or interact with my documents just as if I had a tablet. However, where I use VR the most is to get inside our models. An important part of designing a building is communicating that design to the people who are going to build it. And when we are doing the design, we also want to make sure everything is going to work when they build it. To make all this happen, most projects have multiple 3D models built before construction begins. Oftentimes we use these models to coordinate between the architectural design and the design of the various engineers that are involved in the project to make sure that there are no unexpected issues like pipes running into walls or beams sticking below ceilings. Sometimes we use these models to convey the design intent to people who aren't as familiar with reading construction drawings, or even to the rest of the design team when the design is more complicated. The model that we're in now is the fabricator's model that is used to fabricate the timber beams and floor panels that will go into this project. Not only can we see all of the major components, because of the way this model was built, we can see every screw that will be used on site. Because everyone is able to walk through the model together, when we see a problem, we're able to solve it together in the model before it becomes a much more costly problem in the field. Virtual reality is one of the many new and emerging technologies that architects, contractors, and engineers rely on and use on a regular basis. Well, that was a great overview of some of the things that ACE professionals do. It was also just a small sample of the range of careers in the ACE field. We also saw some exciting technologies from some of the mentors. I think it's also safe to say that the roles and responsibilities of ACE professionals will change as technology evolves in ways that we might not even know yet. If you think any of those things are of interest to you, a career in the ACE fields might be right for you, and we're here to help you learn more and help start you on your journey.